One thing, chopped salad, potatoes. Okay, done with the stories. All right, I know, got it. They have new salads there too, if you noticed. All right, so I do, let's see if I have anyone on there. All right, let me go to my old calendar and you will see this now. Itchy, itchy. I'm scratching my nose. Oh, it was right there. Okay, I put this big announcement. Wrong. I hit the wrong thing. Oh boy, good start. There it is. Hit the wrong year. Okay, here's our current calendar, and then at the bottom, shh, gosh, okay. Oh, I'm frozen. Okay, got it. I can never know what you're talking. You're always all right. And there it is. I finally ended the calendar. Finally, I did put this here for first hour, real quick, and I'm making a movie to stick in there. Then there's this calendar here. I think I did just make it active for you. That's just so we don't have to keep scrolling over and over and over again. Okay. So what we did first was a walk around kind of thing. Let me just show you what the answer should have been. Hide this. Here's our master calendar. Just to give those that are absent, we always get a lot of those. Um, what we did walking around. Okay, just to make some points though, zero product property. Happening on this one after you factor a GCF, so hopefully all worked out. But I really wanted to get you on your unit circle values. Seem to be good. Got to get away from the unit circle in front of your face. But I will continue with putting the unit circle up here because it does deal with today. Then, unfortunately, number 3 was a graphing calculator question, and it gives you this negative angle measure, but I was able to go around and hopefully get you to understand how to get those from 0 to 2 pi. All right. And then it basically was this is a reference angle, and then this one's 2 pi minus 0.412, and then this one's pi plus 4.12 is correct there. And then the only thing I did on this one, we did 4. This was an MA factoring, right? And I don't know what we got to do about factoring. Seems to be a lost art there. Remembering that you factored in math 2, math 3. We factored a whole bunch in the beginning of the year. So good foiler, say it. You just check. You check. This gives me negative 2 cosine and 1 positive cosine. That gives me a negative cosine in the middle. Then 1 times negative 1 is negative 1 for the last. So really make sure you check those components. Then you can do the zero product property. One thing I did want to do, give that group credit over there. They actually read the directions, all right, and actually did all solutions, not just from 0 to 2 pi. You were the only group all day long that did that all by your lonesome, I believe. So that was good. All right. So reference the calendar. Now we're going to go to our little notes here. By the way, go to your homework. Let me put that on the calendar real quick. Sometimes I feel like there's too much or whatever. It's going to be in red. Darn it. I hate when that happens. Just do the odds at least. And then this leaves those that some people ask me, what can I do to do more? Well, then do them all. I'm just going to check that you did the odds just to, hey, let's get more people doing their homework daily kind of thing, because that's been kind of poor. The no homework doers are the ones that are getting destroyed in this class really, really bad. So let's try to at least do that after our notes for the day. And then, sorry, first hour, no one will watch this movie that was already here, but I did number 1 a little bit wrong with first hour. Be happy to admit it, but it's because I didn't read my directions. I was just trying to go real fast. I'm not going to read all the above stuff. We are now going to talk about cotan, cosecant, and secant solving, which I was going to have this out when you were doing the board work stuff. I forgot to do it first hour, and I was pleasantly surprised first hour knew their unit circle, and no one had one out in front of their face. But I do want to reference this for secant, cosecant, and cotangent. Remember, cosine is the x-coordinate, so that means cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. But what does that mean about secant and cosecant? They are what's of sine and cosine. Starts with an F, our easy word, flips. So what does that mean the cosecant of pi over 6 is? root 2. What's the secant of pi over 6, or pi over 6? Yes. 2 root 3 over 3. So it's 2 over root 3, and then you go from there. So we got to be able to do this. I'm going to show you maybe another way one more time, but a way I showed you before our test Thursday, because I'm trying to get more people on board. Something has to be memorized. Those that still can't do from February 1st, you are going to continue to get destroyed. All right, we have got to get these ratios down. So I have another way that we could do this, and I'm going to put it in the top of our notes. Remember, root 2 over 2 comes from 1 over root 2. We just had that number 1, right? You had the square root of a half, correct? And that was 1 over root 2 plus or minus. So what's the flip of 1 over root 2? Root 2. So secant and cosecant, both of over 4s, are root 2. All right, getting used to these ratios. All right, and then it just switches for over 3s. So cosecant of over 3 is 2 root 3 over 3. Secant of an over 3 is 2. All right, just knowing these ratios of what happens. So it really, that's why I wanted to reference this before moving on to this. All right, now let's get into it. And then I'll apologize to first hour and tell you what I did wrong with them. But here we go, AP question. Instead of just solve this equation, you got to read and assess what you're doing here. So f of x equals this, g of x is equal to this, great. And in a xy coordinate plane, what are the coordinates of intersection of the graphs of f and g from 0 to 2 pi? Well, that just means when are these equal? Input, say it. But I need both input and output. That's what I did wrong at the end. So just hold off on that. But the points of intersection are where the two graphs are equal. All right? This is now a no calculator question. Oh, I said I was going to do this. Gosh dog it. Here's what you should write at the top of any test, especially if you're at level 1. All right? We still should be writing sir, kixer, ticks. And then I'm going to maybe talk about this way more, because this is what we did right around February 1st. I did do angles in degrees, and I showed you a 30, 60, 90, right triangle, and then we did put sides on those. The side opposite the 30 was 1. You guys remember this? You should. Side opposite 60 is root 3. Side opposite the 90 is 2. That's where these ratios are coming from. That's where sine of 30 is 1/2. That's where cosine of 60 is also 1/2. And so on and so. We did that. All right. And again, people come to my class, when did we do this? We did. All right. And then one more thing is maybe the 45, 45, 90. 1 root 2. 1 squared plus 1 squared is 2. And then you square root it. Those are the side measures for a 45. That is why the sine of 45 is 1 over root 2. We did that. But then 45s are over 4s in radians. One more thing, I probably should have centered this better. ASTC. What does that tell you? Where all those trig functions are positive is correct. All right? But now what we got to do is understand for cosecant, it's the flip of sir. So cosecants are over y. We've already done this. This is just reiterating in your brain after break what we should know. Secant is r over x. Cotangent is x over y, not y over x. So I had to put that back again in case you don't know this right off the bat. Many of you do, though. If you know what this answer is in radians, you're fine. You don't need to do what I'm going to do next. As a matter of fact, I'm erasing that. Where does negative root 3 over 3 come from? This, negative 1 over root 3 unrationalized. And that should not be a hard jump. Everyone should understand that in this classroom right now. What did I just say cotangent is? What letter over what letter? So what are these two letters? What letter over what letter? 3, 2, 1, go. X over Y. Much better than first and second hour. They weren't talking much today, which I understand. All right. Now, the reason I like this is because I told you this before break as I was trying to review and get more people on the bus of figuring out these reference angles. Y is always the opposite side. So Y always denotes who the reference angle is. So what is a 60? Is that an over 3 or is that an over 6? Which one is it? It's an over 3. So the Y tells you which reference angle I'm dealing with, because it is always opposite the angle that's attached to the origin. This is a different way. This is what I did all last year with all my students. It wasn't just rote memorization and jamming the unit circle in your face. All right. So something has to happen though, because this is the only reason people are failing. It's the only reason, because you still don't have these down. All right. And then where's cotangent negative in what quadrants? Where's cotangent negative? ASTC, look at your thing and then tell me. 3, 2, 1, go. 2 and 4. Now I can't help you on this. If you don't know how to get these over 3s and 2 and 4, I'm done. 3 pi over 3 is pi. You jump backwards to get in quadrant 2. And then in quadrant 4, you compare it to 6 pi over 3 because that's 2 pi. We have done that too much, and I've discussed that too much to not know how to get 5 pi over 3 after that. I do think we were good on the boards, though. It was good to see that you do know how to get these ratios. This is what I did wrong. Input, say it. The directions say, give me the coordinates of intersection. So these are the coordinates. When I input 2 pi over 3, my output is what I was looking for, that negative root 3 over 3. When I input 5 pi over 3, my output is also the same. Those are the coordinates of intersection. I didn't do that first hour. I just said x equals 2 pi over 3 and 5 pi over 3. AP directions, right? They are always complicated. It's never just solve this and then move on. Okay, so I know you got to catch up there a little bit. We will start the next one by reading as you finish writing. Let f of x, let g of x, great. In an xy plane, what are the x coordinates of the points of intersection? Okay, just the x coordinates. So I'm just solving for x. And the points of intersection are when these two graphs are equal. So again, the AP version of these. Read the question and assess what they're asking and then set up the situation. You'll see how easy this should end up becoming. All right, I should not have to write this out. Subtract 3 is 8, and then divide by 4 is 2. So cosine of x is 2. By the way, 2 over, I asked this a billion times. What's the bottom? 1. And then what's cosecant? What letter over what letter? This is why you write sur up there, but then cosecant is the reverse of that. So what letter over what letter? Yeah, it's that simple, folks. And this is a different way of maybe doing this, or you already know. What is it, an over 6 or an over 3? Who already knows? Which one is it, over 6 or over 3? It's one or the other. It's an over 6 is correct. Here's why. Because the missing x value is root 3. So it is a 1 root 3 2 relationship. But y is the reference angle. So y is opposite 1, or 1 is opposite 30 degrees, which is an over 6. All right, so 30s are over 6s. That was the connection way back in February 1st. Well, when we moved on to radians, that was the connection. So early on in February. So this is an over 6. And then where's cosecant? Where's sine positive? What quadrants? Come on, it's 1 and 2. So I need the over 6s in 1 and the over 6 in 2. 6 pi over 6, jump backwards to 5 pi over 6. Not staring at a unit circle. Okay? We've got to move on from that. All right, and the directions do say from 0 to 2 pi, so I'm good. It's not the all answers or anything like that. Okay, so maybe this new way can help some others if we're not investing in the unit circle or just can't do it. It's really what I did last year and ended up working out well too. It's one or the other. I don't know. They're both equally valid ways of approaching this. All right, and then the last one I'm going to chammer on about, then I'm going to let you work on 4, 5, and 6. Same thing. What are the x-coordinates of the points of intersection? The x-coordinates of the point of intersection are if these two graphs are equal to each other. And maybe I'll slow down the k of x equals 4. All right. So I got to subtract 3. And I'm going to slow this one down because we don't like our fractions. Been a fraction jerk. I've been a jerk in general all year long, but definitely a fraction jerk. Okay? I told you, don't divide by -1/2 because most people do it wrong. Multiply by the reciprocal, and then these cancel. So multiply by the reciprocal. And actually, I don't need much room on this. So this is -2. -2 over, come on, 1. So why did I hold off on the negative? Because the negative is actually on the 1, not the 2. And then what's our reference angle? Is it an over 6 or an over 3? Look at the last question. Look at this one. We should be able to figure it out. Over 6 or over 3? It's an over 3 because it's secant of the same ratio, which changes the angle measure. It's like the unit circle here. How do they get that so fast? There it is. Good. Boom. It's because I went from here to here because these coordinates switched. So that's why that's happening. That's how people have this memorized. That's how they're doing this quick, everybody. But if it's not quick, this is R, this is X. Oh, by the way, then Y has to be √3. Y is always the reference angle. √3 is opposite an over 3 or a 60. So you have an over 3 in which quadrants? Where is secant negative? Look at ASTC. Where's secant negative? 3, 2, 1, go. 2 and 3. I should be using that symbol, 2 and 3. So what's the over 3 and 2? 3 pi over 3, jump backwards. And then, secant's negative in quadrant 3, jump forwards from 3 pi over 3. I've said that too many times to not know 2 pi and 4 pi over 3. Way too much. All right, so here we go. 4, 5, 6. I'm going to leave the movie for a second because I can't pause it. You guys work on those real fast. First one, by the way, is already zero product property, so you should be doing what we did on, I believe it was number 2 of the day. No, number 2, you had to actually factor, then use the zero product property. 5 is a GCF, and you should darn well know what to do on 6. When you square root both sides, what happens? What happens when you square both sides? Everyone say it. Plus or minus. That can make your life better. Never answer 2 pi. If that's an answer, it's always 0 instead. 0 and 2 pi are the same angle. They're coterminal. That's the same angle twice. 0 is doing nothing and 1 is close enough. 2 pi is doing a quarter of 60, which is very nice. You really get to know that? Oh my gosh. You are no time. No time. Oh my God. No time. Yeah, I think a bigger class we took a little too long on the first part. Sorry. Because the next part is not so much a fun And I see what my counterparts did for the next one. I might just do it that way with you guys, and then yeah, then first and second hour got a little extra fun. I don't know if I'd call it that for them. Okay, we're running short on time. Anyone at least get the first one? No? Okay, that is zero product property. By the way, cosecant of theta equals 0 over. Come on. 1. How could R be 0 and 1 be Y? So what happens with cosecant of theta equals 0? No, 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 no solution. All right, and then root 2 definitely gives me a solution. So what I should have got for root 2, finally, the over 4s, right? So cosecant of root 2 over 1, whenever you see root 2 for cosecant or secant, you instantly have to have an over 4. And then it's just the quadrant game, right? Next one, same thing. You do a GCF. We're going to run way out of time on the calculator part. Take out a secant, and then secant of theta equals 0 also doesn't lead to answers. But secant of theta equals 2, we just did that one, but now it's quadrant 1 and 4 over 3s, not quadrants 2 and 3 when it was a negative 2. I see you all scratching down. We are on limited time. So I'll show you the last one, but maybe just let it sit in your head because I got to move on. When you square root, what did you say? Plus or minus. Now be careful, cotan and tan. Cotan and tan equaling 1, that's actually the 45s. That's the over 4s. Plus and minus thing is the greatest thing that ever happens to you because you get all 4 quadrants involved. Just have to deal with all 4 quadrants. And I still see people scratching down like crazy. All right, just understand it, and that's really what has to be done. And I put that y because r would have to be root 2 for the Pythagorean theorem. That's 1, 1, root 2 triangle. That's a 45, 90, which is an over 4, which we did make that connection way back in the day. Now, this disaster. And then I see what my counterparts wanted to do this. I did this by hand, then used my calculator. I'll show you what my counterparts did, but this requires a little bit here, something you've never done still. So go ahead and get your calculator out. Get your mode in radians, otherwise your graph will not work. And this is, again, the first time we've ever done this, like going to the graphing calculator to look at a graph. We may have done it with sine and cosine. I don't even know if we did it. Yeah, we did because we did regressions with that stuff. So we did look at the calculator there. Okay, so again, let's look at these silly little directions. Let P of x equals, in an xy plane, what are the x coordinates of the points where P of x equals 2? So that just means I put 2 here and solve this equation. And we are, what I did in the other hour was we did it by hand, like we did number 3 in our bell work. And I think I'm going to hold off on that, and I'm going to show second and first hour how to do what we're going to do here. But here's the problem. This would be great to use a graphing calculator, except what button don't you see? You don't see cosecant. What else? Secant. And what else? Cotan. You don't have a cotan button. And I don't know why, to this day, why the TI family won't give us that button. It doesn't exist anywhere, even in a catalog, even in a menu. So here's what we got to understand. This is the same as cotan 1 over tan of this angle measure, because that's what 0.5x minus 1 actually means. That is the equivalent, and we have to do that in order to see this graph. And then what we're going to do is put this in y1 and y2 and find the what? The intersection. But that requires some stuff. So let's go ahead and first of all type these in. Ooh, I'm at 1102. So y equals 2. And then y equals y2. Maybe I could shrink this. So I think it is ready to be. Yeah. Yoink. Not enough. So you guys can type better. You can type better to me. I can't even move this thing. 3 minus, and then I'll show you what I typed here. 1.7 parentheses. Now I'm going to go ahead and do the fraction button for time purposes. Second y equals fraction, and then 1 divided by tan. Oop, almost hit cosine. Tan of that 0.5x minus 1. And then those minus 1, almost didn't finish that. Close that off, and then I'm going to zoom this out again. Okay, so notice what I have there exactly as it looks. If I wanted to close that last parenthesis, then I would go out on the outside and then close it. It actually does not have to be done. Okay, so here's the problem. I don't have a cotan button. You don't have a cosecant. You don't have a secant button either, so you'd have to go through this process. Now, the next thing is go to Zoom and go to Zoom 7. Because what is Zoom 7? What does that say? Zoom what? Trig. And let's hope for the best that it actually shows me a nice little picture. And it does. Okay, and then that, we do have kind of like that cotangent looking graph with some things being done there. All right, now what are the directions? Find the answer from 0 to what? 2 pi, which is 6.28, right? So I have a good feeling about this point right here. So that's the intersection I'm going to find. Second, calculate intersects, boink. And then first curve, move over to this one. That's the only thing you have to do with first curve. Get close to where it's at. Whoops. I accidentally hit that arrow. First curve, enter. Just hit enter. Just hit enter for guess. It's the same thing. 1, 2, 3 hits. The intersection is 4.078, which is 4.08. So that's how we can do this one. I won't show you the algebraic method because I think it's a little too challenging. Okay, so 4.08 was the intersection x coordinate that gave me the output of 2 for both sides of the equation. All right? All right. So one more time, as you're packing up, some are still looking up here, though. Y equals. Got to be able to understand I don't have a cotan button. Once I do, zoom trig and hope for the best that you do see this. And 4.08 is between 0 and 6.28. So I know I'm good. All right. Odds. At least do something, not nothing.